I'm Jenna. I'm a geologist here in Santa Barbara. Today we're at Goleta Valley Junior High. Behind me you'll see the transverse range, which is the mountain range that runs here in Santa Barbara. Something very unique and special about the mountains and the ocean here in Santa Barbara is that for most parts of California, the ocean is to the west. But here in Santa Barbara, the ocean is actually on our south coast. So what we're looking at right here is actually north. The mountains are always to the north here in Santa Barbara, and the ocean, which is that way, is always to the south. So that is west, and that way is east. What we can see right here from the actual schoolyard, right behind us is an area known as Lizard's Mouth, which when you are up there and look at it from the side, it looks like a lizard with his mouth open. A little bit further to the east here behind me is an area that's called the playground. It's got a bunch of rocks that are exposed there as well. And then a little bit to the east of that, or a little bit to its right from here, is Highway 154. Say that both of those sandstone units belong to a formation called the Coldwater Sandstone, and tens of millions of years ago, those were actually beachfront property, more or less. They were deposited on the beach like sand is being deposited today. That tells us a little bit about some things that have been happening to this region of California. All of these mountain ranges here have been created through what we call in geology compression, which is basically like taking an accordion and pushing it together, or taking the crust of the earth and sort of scrunching it up to create these mountains. I'll point out some really iconic sort of sandstone formations here in Santa Barbara. To my right is the highest point in Santa Barbara County, which is LaCumbre Peak at 4,000 feet. To the left of that is Cathedral Peak, which is the second highest mountain here in Santa Barbara. And to the right of that, even though it looks like it's taller, is Arlington Peak, which is the third tallest mountain here in Santa Barbara. So if you're standing in Santa Barbara, let's say you're standing at Santa Barbara High School, you actually have sort of a straight-on view of these mountains. To the left of LaCumbre Peak, Arlington Peak and Cathedral Peak, is Highway 154. Highway 154 is sort of situated in that valley because there's an active fault that runs through that valley. When we think about faults in California, the most obvious fault that comes to mind is the San Andreas Fault, right? It's the really big fault that runs through California that creates, all of the earthquakes and tectonic activity that happen. However, it's not the only fault. There's faults everywhere throughout California, and specifically many of them here in Santa Barbara. So, like I said, the 154 is a fault, which again is just this point of weakness in the rock, where the rocks are sort of either pushing up on one another, or sliding along one another, or falling apart from one another. And it's actually what creates the topography of our foothills and the mountains themselves. So you can see that there's kind of a hill right behind me, but then behind that hill there's another valley. And that's because there's a fault that runs on either side of that hill. So that hill is being pushed up on one side, and then the land on the other side is being dropped down. And then on the other side of that fault, more land is being pushed up, and on the other side, another part is falling down. That's what gives you this sort of rolling hill topography throughout the entire range, and throughout Santa Barbara in general. If you are to stand up at, say, the San Marcos Preserve, which I think has one of the best views in Santa Barbara, You can look out at Hope Ranch. You can look out at Arroyo Burro Beach. You can look out at the Mesa, as well as all of downtown Santa Barbara, like the Mission and so forth. What you would notice if you looked out from those points is that the Mesa is the Mesa because it's uplifted. Hope Ranch is also uplifted, right? It's sort of high above everything else. Those are some other major faults that are running through Santa Barbara that are pushing up the Mesa and Hope Ranch, more Mesa, while the land around it is being dropped down. All right, as you can see, we've moved locations a little bit, but we're going to be looking at some geologic maps. These are Dibley maps. They're resources that are available to you here in Santa Barbara. You can purchase them online or come to the Santa Barbara Museum of Natural History, where we archive all of them. What we're looking at here is, so here's the ocean down here to our south, and we're looking north up into the mountains. Just to orient you, here, so Goleta Valley Junior High is right in here, so we're looking at the coastline basically that spans from UCSB over here, right? Here's Goleta Beach in here, Santa Barbara, going out to the east. So Goleta Valley Junior High then is right here. You can see, so these different colors on this map, there's a key on every map that will tell you exactly what these colors correspond with, what type of rock, what age those rocks are. And there's also a key that tells you what a lot of these symbols mean as well. So dotted lines like this mean that there's a fault inferred here. We can't see it visibly at the surface, but we suspect that it must run through there. The solid lines, like the San Pedro fault up here and the San Jose fault over here, those are faults that are visible from the surface. It doesn't mean that there's like a big chasm in the earth. It just means that we are able to figure out that some of these rocks are sort of falling down and some of these rocks are being pushed up. If we go back to looking at Goleta Valley Junior High right here, something that's really cool to note is that right behind the school, causing really no harm to this area, is a fault that runs right behind the schoolyard. You can see it from the back of the schoolyard simply by looking up at the mountains. There's a big white house that's on the up block of that fault. So the land we're lower than that hill, and on the other side the land is lower than that hill. It's a really cool feature to see from the back of the schoolyard. Something else that's noteworthy in these maps is that you can really easily find local creeks and watersheds. You see all of this light-colored rock, or all of this light-colored, these like finger-looking things coming up through the different formations. Most of those are creeks, so that is a really good way to sort of point out different watersheds. So right here is the San Pedro watershed. Over in here is San Antonio Creek, right? That comes right through here. So all of these watersheds then are filled with this much younger rock. So right, like up here is the mountains. Obviously the mountains are higher than the rest of Santa Barbara, so it makes sense that water is flowing down from a high place down to a low place, and as it flows down, it's carrying sediments with it and depositing all of that sediment within these creek beds. So all of these creek beds are filled with sort of much younger sediments than the surrounding hills and mountains in those areas. On a broader scale of Santa Barbara in general, you can see that Santa Barbara itself is sort of what we would call a floodplain, or sort of a fluvial or alluvial plain. Right? It's it's filled with all that younger sediment, which means that it's sort of the catch basin for all of the water and all of the sediment that is eroding off of the mountains. Coming down through all of this, something that's sort of a noteworthy feature. So this map up here is sort of an extension of the mountains. What we're looking at is the highest parts of the mountain, as well as what's behind those mountains. So this back here is Lake Cachuma in all of that area. So if we start here at sort of San Marcos Ranch, we can follow the 154 down, right? And then it sort of winds down through here. The 154 is placed in the area that it's placed because there are some major faults that run along that canyon that actually create that canyon. So before the 154 was actually a man-made highway, it's always been a very sort of natural feature in the landscape that allowed people to get through the range itself, from the back country to the front country, specifically because the faults around it are sort of clearing the path for things to be transported through that gap. Like I said, when we think of faults, we often think of just the San Andreas Fault, but a really important feature to the geology of Santa Barbara are all of these much smaller faults that run through our region. They create a lot of natural passageways for us as humans to travel through Santa Barbara, but even more so for the watersheds that run through our local area. All right, so it's a little bit tricky to see, but running up through here is Highway 154. It kind of snakes along up through here. Because of these faults that run along here, so again, sort of dotted and dashed and solid lines that run through this map represent faults. On any one of these faults, you'll always see a D and a U, right? So here's one on this fault, here's one on this inferred fault. That D and the U stand for down and up. What that means with the fault is that on one side of the fault, the rocks are falling down. And on one side of the rocks are being pushed up. So the 154 is running through here, and you can see that the landscape of this area sort of lends itself to this natural pass by having all of these sort of down blocks situated up the side of the mountain. It sort of clears the path in a very natural way for the 154 to run through here. These faults are just weak points in the rocks themselves as this area is getting totally compressed, pushed this way, and scrunched together. These are just weak points where the rocks are sort of faulting and breaking. They're brittle, right? And so that's what's sort of creating that crunching, that accordion-like compression that's happening. On those weak points then, in addition to them being fault points, and one side coming up and one side going down, you also get increased erosion, right? So erosion is just sort of natural forces like water and wind over time breaking down those rocks. These creek beds where we can see all of these sort of like fingerlings of the watersheds. Watersheds are amazingly erosive environments.